We are measuring only physical quantity and this doesn't apply for non-physical quantity. Thermodynamic temperature, the unit is given in terms of Kelvin, whose symbol is K. The method to identify slope is by using tan theta is equal to opposite by adjacent formula. A few instruments which we are studying, that is meter scale, screw gauge, vernier calipers, spirometer. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru. Here, I welcome you all to the session 1 of chapter 2, that is units and measurements. So you all know what is this units and measurements. So-called measurements. You all know that you measure certain things. You measure the length of a table. You measure the length of a tree. You measure the length of a stick. You measure your weight. That each and every measurement, even you measure your length, your height, right? So each and every measurement are in numbers. That is, it is given in magnitude. It has got certain numbers. Your height has got certain numbers. Your weight have got certain numbers. Like that certain number, it implies nothing but the measurement. The measurement is given in terms of numbers. So that certain number, if it is length, you measure it. So you get some number, certain number, maybe 10. 10 what? 10 centimeters or 10 meters. So something is there suffix to it, right? So if it is measurement 10 what? It is centimeters or 1 meter or 2 meter, anything like that. So that this is known as unit. This is known as unit, and this, whatever we have measured, this is in terms of number and it is called as measurement. The measurement will always come along with the unit so that we will get to know whether we are measuring the length or whether we are measuring the weight or whether we are measuring a height or a distance, anything like that. Okay, so this is all about unit and measurement. So, measurement of any physical quantity, we are measuring only physical quantity and this doesn't apply for non-physical quantity, okay? So, measurement of any physical quantity is expressed by a number. I told you it is expressed by a number. The measurement of any sort of physical quantity is expressed by a number which is accompanied by, it is accompanied by a unit. It can be centimeters, meters. If it is time, it can be seconds, like that. Okay. So unit, it is reference standard. It is used to measure any physical quantity, that it shows the which physical quantity. It represents which physical quantity we are measuring. So next, it is base unit. So there are certain base unit. Okay. So here we are studying 7 base units. So what are this base unit? It is adopted for the measurement of base quantities. There are certain base quantities which we'll be studying in the next slide. So here it is a base unit. It is used to study the base quantity. It is used to measure the base quantity. Okay. So few base units are, it can be meter, kilogram, second, ampere, Kelvin, mole, candela are base units. Okay. So base unit is done. It is clear. Now, what is derived units? Derived units, for example, if you have got only 2 colors to paint with you, that is a red as well as white. If you are having a bottle of red paint and a bottle of white paint, you need a pink color. You require a pink color, but you don't have a pink color with you right now. They have given you red paint as well as white paint. So what do? You just mix it up. So on mixing, you will be getting a pink color, right? So red, plus white, mixture of red and white, what it will give you? It will give you pink color. So it is a derived color. So these are the base colors, as well as this pink color will be a derived color. Similarly, it comes up to the unit also. So base unit, it is a one which is applied for basic quantities, certain base quantities. Okay. So what is this derived unit? The units which are derived from these base unit is there, no? Those are called as derived units. So there are few derived units we'll be discussing in the next class of ours. So base units and derived units together, it is known as system of units. So here previously we studied what is unit as well as what is measurement, and in this slide we have studied what is base unit and few examples for base unit and what are derived units. Derived units, it is obtained by deriving. So deriving from what? From base unit. Derived units are the units which are obtained from the base unit. So base unit is this. Derived unit is the one which is obtained by using this base unit. So base unit as well as derived unit together, it is known as system of unit. Okay. So next is international system of units. So here earlier there was three system of units. It was different, that is CGS system, FPS and MKS system. CGS system, that is nothing but C centimeter, G grams, S means second. So this kind of system was used. And again FPS, foot, P means pound, S means second. Even this kind of system were used. Next is MKS, that is M for meter, K for kilogram and S for second. This kind of system were used earlier in different places. So after research was taken place, certain units were not matching up with these units. Few were using CGS, few were using FPS and few were using MKS. So the at last result, whatever we get in certain units, no, that was not matching. So what they planned to give same units for throughout the world to use the same unit. So what they introduced is SI unit, a concept called as SI unit. So this SI unit, that is System International Unit, this was given in 1971 by Bureau of International System of Measurement. That is, it was internationally accepted for measuring certain quantities. So it is known as standard unit. Okay, all these are known as standard unit which are internationally accepted. It is accepted throughout the world. So each and everyone are having common units, that is given as SI unit. So System International, it uses decimal system. So here the conversion is very much easier in SI unit system, which is internationally accepted now. These things were used earlier, but now after 1971, the thing which we are using is SI unit, that is System International Unit, which was developed by Bureau International Despots et Measures, that is Bureau of International System of Measurements. So the few base units whatever we are using, let us study about it. That is, first one is the quantity which we are measuring, that is length. Length is the first quantity which we are measuring. So what is its unit? Unit is given in meters. We are measuring length of a cloth or length of a stick. That one we are measuring in terms of meter. So this is the unit, base unit which we are using. So now symbol of this unit, that is unit meter, is M. So the first base quantity is length and the unit is meter, whose symbol is given in small letter M. Next, that is mass. So next quantity which we are studying is mass, whose unit is given as kilogram, whose symbol is kg. Okay. next quantity is time. So time is a quantity whose unit is given as seconds. So the symbol of second is given as S. Okay. So the fourth one is electric. The unit of electric current is given in ampere. So its symbol is nothing but A. A is its symbol. Next quantity is thermodynamic temperature. So thermodynamic temperature, the unit is given in terms of Kelvin, whose symbol is K. And sixth one, that is amount of substance. We are calculating the amount of substance. So the amount of substance unit is given in terms of mole. So symbol is MOL. Okay. So lastly, that is the seventh base unit. I told you there are 7 base units. So the seventh base unit is luminous intensity. That is used to measure the brightness of the light. The unit of luminous intensity is given in terms of candela. So symbol is given as CD. So you got to know there are 7 base units, which are those: length, mass, time, electric current, thermodynamic temperature, amount of the substance, and luminous intensity. So you got to know, right? There are 7 base units. These are not derived units. These are base units. So there are 7 base units: length, mass, time, electric current, thermodynamic temperature, amount of substance, as well as luminous intensity. So these 7 quantities are having respective units as well as symbols. So I hope you got to know what are base units, what are derived units, and now what kind of unit we are using, that is SI system, right? SI units. So which are those base units? So we have studied the base units over here. So now, besides these 7 base units, there are 2 more units which are used for plane angle as well as solid angle, which determines the angle. So here there are 2 units. There are for plane angle it is radian, and for solid angle we use steradian. So there are 2 units besides 7 base units which are used to represent angle, that is plane angle as well as solid angle. In order to represent plane angle, it is said to be radian, and in order to represent solid angle, it is said to be steradian. So let us study about the plane angle. So if this is a circle, so here let us draw a radius. Let us make an angle. So let me write it over here. So this will be an angle, and here it will be a outer part of the circle, circumference of the circle, which is continuing over here. And this angle is represented as theta. So let this point be O. And since this represents the radius, so let me write it as R. And the outer arc is there, no? So let this arc be represented as DS. So this is a plane angle. It's a plane angle. Okay. So radian. What is meant by radian? You got to know the picture, right? So now look at the picture and then you will have to give out the definition. This is how you study things. It is very much easier for you to study the definition or define so and so. You can easily study. It's not that you have to by heart things. It is just imagination power which you require. That power you have to cultivate within yourself. Okay. So it is defined as the ratio of length of arc ds to the radius r. It is defined as, that is, d theta. This theta angle d theta. So radian d theta is defined as the ratio of length of an arc, that is ds, to the radius, that is r. So what did we get? D theta is equal to ds divided by r, that is plane angle, that is used for plane angle. The radian is defined as the ratio of length of an arc to the radius of the circle. Okay, so now that is all about radian. Now going to steradian. Here this steradian is defined as, so in order to study this steradian, we will have to picturize a solid angle because steradian is a unit for a solid angle. So let me take up a solid angle. So in this solid angle, so this is 0 and this can be area which is represented as dA, and this angle can be represented as in this way, d omega. Okay, so now coming to the definition. So steradian, the angle, so that angle can be d omega. So steradian is defined as the ratio of the area, this area, to the square of distance, that is square of radius. Okay, so this is the equation for steradian. So what is this steradian? It is defined as ratio of intercepted area, which is given as dA. The ratio of intercepted area of a spherical surface. You are taking a spherical surface for plane angle as well as solid angle. So here it is a spherical surface of apex O as a center to the square of radius. So it is the ratio of intercepted area of a spherical surface which is described at about the apex O, okay, to the square of radius. That is nothing but steradian. So you got to know what is plane angle, you got to know what is solid angle, and in plane angle the unit is nothing but radians, and in solid angle the unit is nothing but steradian. So radian is given as, symbol of radian will be RAD, whereas the symbol of steradian is called as SR. This is the symbol of steradian. So this is for plane angle, this is for solid angle. So plane angle you got to know how it is represented, and in solid angle also you got to know how is it represented. So these two describes the plane angle as well as the solid angle. So coming to the next topic, that is, there are different types of instrument in order to measure certain things. Certain measurement have got certain range, because of which there are different kinds of instruments. So that instruments may few instruments which we are studying, that is meter scale, screw gauge, vernier calipers, spirometer. They are used to measure up to certain ranges. Each and everything are having certain ranges. That is, the small ranges can be measured in terms of meter scale and screw gauge, vernier calipers as well as spirometer. This in your practical level, you people know what is meter scale, right? So in practical sessions, you will get to know what is screw gauge, what is vernier calipers, and what is spirometer. As you do your practicals, you will get to know slowly. So here, this is nothing but screw gauge, this is vernier calipers, this is spirometer, and you all know what is meter scale. You people keep seeing, and you people are also having certain scale, that is centimeter scale, which you use. Similarly, there is a meter scale that you people know. Okay, so these are the instrument which measures the physical quantity up to certain ranges, that is small ranges. When it comes to a big range, that is we have to measure the large distance. In order to measure a large distance, maybe you can take an example of planets. You have to measure some other planet from here. From Earth, you will have to measure the distance of Mars, distance of Neptune, distance of Pluto, or distance of Saturn, distance of any planets or any stars like that. So in order to measure the distance, there is certain kind of method which is used. That method is known as parallax method. Here in this parallax method, it is the apparent displacement of an object when observed from two different places. So here in this image, you can see planet Earth, and from here we are visualizing moon. So this distance is a greater distance. So in order to measure this distance, we are using parallax method. So in order to measure, what is the procedure in order to measure this parallax method? That is the point of observation. There are 2 points of observation from where we are observing moon. So it is point A and point B. This is given as point A and point B. This point A and point B, the distance between these 2 points can be called as basis, which is represented by small letter B. And the distance from this satellite can be represented as S. From there to here, it is represented as D, and this also becomes D. And it is accompanied by an angle. It makes an angle from the point, from the main object up till the distance of observation. It is making an angle, that angle is called as theta. So it can be called as angle ASB is equal to theta. So where S is the observation, object under observation, theta is called as parallactic angle or parallax angle, and S is the object under observation. A and B are observing points, and small letter B, that is called as basis, and D is the distance. So angle ASB is equal to theta. So if the distance is even more greater, what it becomes? So B will be very much less than D. So B divided by D gives you unit, that is 1. Okay. So if you're considering AS is equal to D, then B is also equal to D, which is called the radius. And then if B is the basis, that is B is equal to AB, then this theta is a parallactic angle. You can give D is equal to B divided by theta. Similar method is used in order to calculate the angular diameter as well. Okay, so this is a parallax method which is used to find out the measurement of an object of greater distance. So this is one of the method which we have studied now, that is parallax method. So here, let us study about the numericals now. Let us go into numericals. Here in numericals, say this is a problem which is not at all a problematic. It is just a numerical which is very simple. The main thing which you have to do is understand, read the question properly, list out the given points, and then you have to visualize things and you have to execute. That is a simple thing which you can do. Okay, it is very much easier for you to score marks as well as lose marks. So scoring is easier, right? So you will have to imagine things, grasp the questions, write the given terms, imagine things, and then systematically you will have to put it down. So let us come into the question. Calculate the angle of given values in radians. So use 360 degree is equal to 2 pi. They have given already. So 1 degree is 60 minutes and 1 minute is 60 seconds. So this is degree. This symbol 1 dash, that is called as minutes, and double dash, it is called as seconds. So let us do 1 degree. Let us calculate for 1 degree. We are calculating the angle of given value in radians. Okay. So now we have got 360 degree is equal to 2 pi. So what is this? 1 degree. So it becomes 1 into 2 pi divided by 360. 1 degree is equal to 1 into 2 pi divided by 360, which goes like 2 pi divided by 360. It becomes 180 and you have at last 0.0174, wherein this decimal places is being kept over here. You will study further. I'll teach you like how to shift the places. So it is from this decimal place is moving after 2 places. So if it moves towards your right, it should be -2. If it is moving towards your left, it will be positive of any number, how many times you're moving. So it is 1 and 2. So it is 1.7 into 10 raised to, you're shifting 2 places. So it is 2 places since you're shifting right side, it is minus. So 1.7 into 10 raised to -2 is the radian which you are getting. So it can be represented in units. It is not dozens, liters, meters, nothing. It is radians because you're measuring the angle. So this is all about 1 degree. So it is done. Now coming to minutes. That is 1 minute. So how is it? You have got 1 degree is equal to 1.7 into 10 raised to -2 radians. 1 degree is how many minutes? That is 60 minutes. It is already given over here. So can I replace this 1 degree by 60 minutes? Yes. So it is nothing but 61 degree is nothing but 60 minutes. So 60 minute is so many radians. So what is 1 minute? So again cross multiplication. So it is 1.7 into 10 raised to -2 radians divided by 60. So you have got 1 minute equal to 0.0290 into 10 raised to -2 radians. So let me shift the decimal point after 2 places, that is in this way. So you have got 1 minute is equal to 2.9 into 10 raised to -4 radians. So this is 1 minute. So you have calculated 1 degree as well as 1 minute. So coming to the next one, that is, let us calculate 1 second. So this is, so calculating 1 second. So 1 second. You have got 1 minute is 60 seconds. So this 1 minute can also be written as 60 seconds. So 60 seconds is given as 2.9 into 10 raised to -4 radians. So what is 1 second? So again cross multiplication. So you have got 2.9 into 10 raised to -4 radian divided by 60 seconds. So on division, you get 0.048 into 10 raised to -4. So shifting 2 decimal places, you get 4.8 into 10 raised to -6 radian. So this is how you calculate the degree, minute as well as radian. So now let us go to the next numericals, that is, a man wishes to estimate the distance of nearby tower from him. He stands at a point A in front of the tower C. So imagine, read the question, imagine, okay, a man is there and a tower is there. So let me draw. This is just my imagination. You can't see my imagination. That's why I am putting as a picture in this slide. So imagine this as a tower. So a man wishes to estimate the distance of nearby tower from him. He stands at a point A. Let this point be point A in front of the tower C. So this tower is represented as point C and spots a very distant object, that is O, in line with AC. So in line with AC, he points a very distant object, that is O. Let me give it in a dotted lines. Okay. So next, he then walks perpendicular to AC up to B. Okay. Perpendicular to AC is this. This is a parallel line and this represents a perpendicular line. So perpendicular to it is perpendicular to AC. He is moving towards point B. Okay. He then walks perpendicular to AC up to B. So that point is represented as point B. A distance of 100 meter, at a distance of 100 meters. So this is considered to be 100 meters. Okay, distance unit is given in meters and symbol is m. So quantity is nothing but the length we are measuring. Next, since O is very distant and the direction BO is practically the same as AO. The direction BO is same as direction AO. Okay, so but he finds the line of sight of C. The line of sight of C, it is shifted from the original line of sight by an angle theta, that is 40 degrees. So the given is angle theta at 40 degree. Estimate the distance of the tower C from his original position. We need to estimate the distance from the tower, distance of the tower from the original position, point A. Okay, so you got to know that is he is standing over here and observe in front of a tower which is represented by point C, and he is looking at observing a distant object which is represented by O. He moves 100 meter perpendicular to AC and that point is represented as B. From B, when he view O, the direction of BO is same as the direction of AO. Okay, so now he need to get the distance, exact distance of this tower from the point where he is standing, that is from original place, from A to C, what is the distance. So you got to know, you have completely visualized the question here. So now you will have to execute it in numericals. So we need to find out this distance. So let us take a slope. Slope is always calculated by tan. Okay, so it is tan theta is equal to opposite by adjacent. So tan theta is equal to AB by AC. So AB is equal to tan theta into AC. So AB is equal to AC into tan of 40 degree, because 40 degree is the angle which it made. So now AB is nothing but 100 meters. So AC into tan 40 degree is 0.8390. So it is 100 divided by 0.8390 is equal to AC. AC is the distance which we have to measure. So on simplifying this, we get AC as So AC, the distance is 119.18 meter. So this is how you calculate. See now, the numerical is very much easier. It is just that you have got the question, you have read the question, underlined main points you have written which are given. I haven't mentioned here, but it is like you will have to write given terms. Given AB, the numericals, the measurement you will have to give, that is 100 meter, and angle which it makes, theta, is nothing but 40 degree. So having these, you will have to find out the slope. Since the method to identify slope is by using tan theta is equal to opposite by adjacent formula. By using that, you have got the distance of AC, that is the length is nothing but given in meters, 119.18 meters. So in today's class of ours, we have studied units and measurement. What is meant by units? What is meant by measurement? Okay, and there are 7 units, base units, and as well as derived units. You know what is, you have studied what is base unit, you have studied derived units. Together it makes system of units. And before, earlier they were using CGS, MKS, etc. kind of systems, and now internationally accepted system, that is nothing but SI unit. It is given in terms of decimal, and then it is very much easier for conversion also. So it was given in 1971, which was developed by Bureau of International System of Measurement. Okay, and it is internationally accepted unit. System International, that is SI unit. We have studied seven basic units, and then in order to measure large distant objects, we are using a different method that is known as parallax method. We studied about the parallax method, how it is determined, right? And next we came to instruments, different kind of instrument, because according to their particular ranges, we are using different instrument. Okay, so next is we studied about the numericals, how to read the question, how to obtain the given terms, and how to execute it. So that's all for today. Have a good day. Thank you one and all.